Hello everyone, in this tutorial we will integrate vehicle AI and the road network. From the last tutorial, we have the road network tool that we can create the road from the editor. And we also have the vehicle AI that can follow the spline and avoid the obstacle. Now we will integrate both of these systems together. In traffic tutorial, in the plugin, we have this algorithm plugin. And from the last tutorial, if you don't have the road network tool plugin, you can download, link in the description below. If you already create it, you can go to road project and go to plugin, this road network tool plugin, copy it, go to traffic tutorial, go to plugin and then paste it. Open this plugin, delete intermediate and binaries folder. The same with this algorithm plugin, intermediate and binaries. Delete .vs, binary, intermediate, save.vs config, traffic tutorial.sln. Right click and then generate Visual Studio project files. After we generate the project, we can go to traffic tutorial.sln, traffic tutorial plugin. We have this road network tool plugin inside this project. Go to road network tool, public and private. Go to road actor.h and road actor.cpp. We find this function generate mesh from points. We want to change this so the vehicle will ignore the road as the obstacle. We don't want the road as the obstacle of the vehicle. So set collision. Block mesh component. Set collision profile name. Text. Custom. Block mesh component. Set collision response to channel. ECC visibility. ECR ignore. We ignore visibility channel. When the vehicle do the speed test, the vehicle will ignore this procedural mesh. Save this, then run this local window debugger. After we open this project, we can delete all these obstacles. In this code, but we left this one cube as the obstacle. Delete this and delete this line road that loop around. Go to road network tool and let's create a road network. We can change this thickness to 5 and width can change to 400 and let's click create. And we get this road network. Let's play this. But now we can click on this road network. Go to traffic, BP fly pound. We can get the location of hit location from this line trace because we check for the actor tag is equal to floor. So we need another actor. Set this to road actor and call all boolean. Like to branch. Compile and save. And we play again. Now we can click on this road network. We can close this project and save selected. For our vehicle, about to find the path on the road network to the location, we need to have another pathfinding algorithm. So you can go to this link and we create another struct is f path node is the intersection point of the road, and we have another A star pathfinding algorithm with start node and goal node, and we have all nodes of the road. Download this as zip file. To create another folder, name this to component, drag it here and extract this. We can copy this road pathfinding component.h. Go to our project and go to road network tool, source, road network tool, public, and pass it here. Another one is road pathfinding component.cpp. Then paste it in private folder. We need to create another header. Name this road mesh generator .h. Click yes. Copy this name. In private, create another text document. Road mesh generator.cpp. And yes. And we need to clean .vs. First, we close the Visual Studio project that opened this graphic tutorial. And we delete this .vs binary intermediate. And we generate Visual Studio project file. After we generate, we will include the pathfinding component in the plugin. Open this road pathfinding component.h and .cpp. Go to road mesh generator.h. Pragma 1. Include core minimal.h. Include component Spline component.h. Include procedural mesh component.h. And include road actor.h. We create this road mesh generator because we want to separate the logic of generating the procedural mesh from this road actor. Go to road actor.h and we need to copy this F intersection node, F non-intersection node, F line segment from this road actor. Copy and paste this here. In this road actor, we can delete all of this struct. Go to road mesh generator.h class road network tool underscore API F road mesh generator. Public. Let's set default values for this actor property. F road mesh generator. Then save all. Go to roadActor.h and copy the function that related to the mesh generator. So copy all of this function, paste it inside this class. We don't need this destroy procedural meshes function. And in this road actor, we delete this function, but we leave this destroy procedural meshes. This generate mesh from points. We need to add another input variable is a road actor. The same with generate road mesh. A road actor. Go to road mesh generator.cpp and we include road mesh generator.h. Include procedural mesh component.h. Include component Spline component.h. Include draw debug helper for drawing the sphere debug or the line debug. Road mesh generator. Road mesh generator. And we place the empty function first. Open roadactor.cpp. Scroll down to this generate mesh from points. And we copy this function. Entire function and copy this generate road mesh. Go to this road mesh generator. Paste this here. But we need to change this input. We need to change this input. A road actor. The same with this generate road mesh. Next, go to road actor. Go to find spline intersection node function. And until this fine line segment points, copy all of these functions and paste it here. So in this road actor, we can delete all of these functions. Delete this generate mesh from points function. And this generate road mesh. And we need to delete these rectangle line segments. You can see we don't have any error in this road actor anymore. Now go to road mesh generator.cpp, and we need to change this a road actor to this f road mesh generator. Copy this and double click on this to select and paste here. Change for every function. Because it is inside the class of f-road mesh generator. And these are the points clockwise, and paste this here. Then we need to copy this function and add to this. We need to fix the error in the function from this generate mesh from point. This new object, choose road actor. And change root component, road actor, root scene component, and get word from road actor. This procedural mesh, this dot add, we add to road actor. Road actor, we call this function. And this spline component, road actor, road width, is road width. get world from road actor. This generate mesh from points. We need to add another input is road actor. Change this road thickness. Get world road width. This spline component road actor. This generate mesh from points. Road thickness. For find spline intersection node, we need the input is spline component. Let's change this in this function. Cons array use spline component. Reference spline component. And the same with this function, find spline non-intersection node. Copy this. And let's go back to this road mesh generator.cpp. Paste this here. We forget to change this A actor to app road mesh generator. And this another function. And this find spline intersection node, we need to pass in the spline component. This find spline intersection node, we need spline component from road actor. The same with this find spline non-intersection node, spline components. Save this. Go to road network tool line tool customization .cpp. We need to include the new road mesh generator. Include road mesh generator.h, because in the road actor we don't have this generate road mesh function anymore, so we need to delete this. Change app road mesh generator road mesh generator generate road mesh function, we has the selected road actor. And we can delete this. If we select on this road actor, we generate the road mesh when we click the button and save. We can try build this by press Ctrl B. See if there is any error. We get some error because we don't need this use struct blueprint type. Delete this use struct. We get this error because of this generated body. So we can delete this. Delete this generated body. Save and run this. Now we start initialize the project. We don't have any error. Let's check if the function is working normally or not. Change this width to 500 and this thickness to 5, and we create, and it is working. We can close this project. We can close this project and save selected. Go to roadactor.h and roadactor.cpp. We want to create another Spline root component and mesh root component, and all the spline is the child of this root, and the procedural mesh that we generate are the child of this root component. Copy this root scene component. Rename this to Spline root component. And this one is mesh root component. Go to roadactor.cpp. When we create this road actor, we the component to static component, root component, mobility, a component, mobility, static, line, root component equal to create default sub-object using component text line root component, and we attach to root component. Set up attachment root component and set mobility component mobility static. In this component mobility, we have static, we have movable, mesh root component, and copy this. And this name is mesh root component. Mesh root component. Set up attachment. Attach to root component. And we copy this. Set this mesh root component to static. Save. Go to this road network tool editor folder and go to tool. Open road network tool line tool .cpp. Find create spline function. Here we create spline. When we set up attachment, we need to set up to spline root component. Spline root component. Go to road mesh generator, and when we set up attachment, we attach to mesh root component. Go to road actor.h. This variable procedural meshes and these spline components. If we have a lot of spline, the actor won't be responsive to the selecting. So change to edit default only. Change this visible anywhere to edit default only. Save all and run this. We have some error here. Unknown specifier edit default only found while passing variable specifier. This error happened because we forgot S with this default. Change this to edit defaults only. Let's run this. We can delete this road network. Go to road network tool and create this again. thickness is 5 and let's click create. When we click on this, we can see the detail. We have Spline root component and mesh root component. Inside this, it contains the spline component of the road, and inside this mesh root component, it contains the procedural mesh component. So it's work as expected. Next, we want to change this. We need to set up the width of this road after we create. So this is the debug width, and the road width is inside this road network actor. Close this project, save selected. Let's change this width to debug width. Copy this. Use property visible anywhere. Name this category is road property. Float road width. Go to road actor, and this we change to debug width. When we draw in event tick, we draw the debug width, not the road width. And go to this road mesh generator.cpp. Go to this generate road mesh function. When we call generate road mesh, we set road actor road width equal road actor debug width. Go to road network tool, line tool. And apply property. We need to change to debug width. In road actor.cpp, this draw debug road width function. This road width we need to change to this input is width. So this draw debug road width, we call this debug width to this input. Save all. Let's run this. In this traffic folder, we want to create another folder. Name is material. We want to change this road material. So create another material. Name is mroad. And Press 3, hold number 3 and left click. Set its material color to gray. 0.39. Green and blue. Click OK. And connect to this base color. And change this roughness to 1 to make this more rough. And create convert to parameter. This parameter name is color. Apply. Save. Next we create material instance. We save this. We can go to road mesh generator. When we apply this material, we need to change this to the location of the new material. Game, traffic, material, M road in, dot M road in. Make sure that your folder is the same name, graphic, and then material. And then this is the name of our material. Save this. Go to road network tool, line tool, .h. We want to change the tool a little bit because we don't want to enable the spline intersection every time before we can use better algorithm that is faster. So add another variable. And this meta, we don't need this because it is Boolean type. Enable spline intersection. This means that the spline can intersect each other. Set it to true. Go to this road network line tool. And in this gconfig, we can copy enable debug line. As down here. Change this name to enable line intersection. Copy this. And then copy this. Set bool. And scroll down. When we check is line intersecting spline, we use this property. If not properties, enable line intersection. and copy this inside, delete this. Go to road network line tool customization .cpp, and in this detail builder we need to add the new variable and copy from this. Change this name to enable line intersection property. Use road network tool line tool properties. Enable line intersection. And this property name, we change this to enable spline intersection property. Let's save all of this and run this project. Let's click on this road network. Go to road network tool. You can see this new boolean that is to true. We change this width to 400, thickness to 5, click create. And we have the different material, that is this emerald ins. Go to selection. And you can see this is the road width is 400. So this road width is different from this width. If we change this to 580 and we don't click create, this road width won't change. Go to traffic, BP vehicle AI. We need to modify this vehicle AI logic a little bit. In this find base target location, we change this spline to default spline, which is the primary spline of the vehicle to follow. Copy. And this distance target to spline, we need to multiply this by 2. And this score, we don't need this dot product. To control the speed, if the vehicle is near the arrival target, we need to slow down the vehicle. So go to this final target arrival. Here we get actor location, distance from Get final target location less than. Move this down. Get vehicle movement component. Get forward speed. Multiply this by 5. If it's less than this forward speed, create a branch. Get min speed. Multiply by 2. Set this to max speed. If it's true, connect this. Comment on this. Press C. Name it to near arrival speed. Compile. Search for max speed. Change this to 25. You can go to vehicle speed control and calculate brake input. I can adjust this range to 45. Add a cell. Like this. Let's set this target. Next, I want to change the color of this material, this floor material. Search this material and we copy this MI prototype grid gray. Paste inside this material. Open and we change the color. Surface property. This surface color. We change it to brighter 0.8. 0.8 and 0.8. Okay. Save and we use this material instead. Like this. And this floor is white and this road is gray. Can go to the wall blueprint. And when we begin play, we don't need to print string this vehicle mode. And we can close this project. Now we will work on the pathfinding for the road network. Let's include road pathfinding component .h. And under this mesh route component, change this category to pathfinding. Use road pathfinding component. Pathfinding component. And we create another function. We expose this function to Blueprint, so we can call this function in Blueprint. New function. Blueprint callable. Category. Pathfinding. Void. Find path road network. F vector. Start location. F vector. Target location. And we need to add another variable. It's private variable. Here, he share pointer and F path node. All path node. This is the path nodes of the road network. For road actor.cpp, this road actor, we need to create this component, pathfinding component. For create default sub-object. New road pathfinding component. Tag pathfinding component. Then we create another function, void a road actor find path road network. F vector start location. F vector target location. All path node. Wall to pathfinding component. Find all nodes and input is Spline components. Then we find the closest node Please share pointer F path node. Start node for to pathfinding component. Find nearest node by location and the start location. All path nodes. And then we draw debug sphere. Get world. We get the location from start node. The radius of the sphere 100 and segment 12, color red, fall, duration 10 seconds. Here pointer we can copy this and change to add node from target location. And this change to add node location. The array is pointer F add node. Add nodes equal add finding component call a star add finding from start node to add node. All add nodes. The array F vector add equal to add binding component get location from add node. Add nodes. If add name greater than 0, we need to draw debug sphere for on F vector reference location add. Copy this, draw debug sphere. And use this location. The color is green and radius is 50. So let's play this. Create new function. The function name is should use road actor. We need to add another variable. Name this to road network. Variable type is road actor. Take reference. Set this road network. Call multi-sphere trace for object. Get actor location. Get final target location. The radius is 500. Make array. For static, we can draw this debug for duration. Out hit for each loop with break. And this element break this hit result. Hit actor, get text. Get a copy. Wall to road actor. And we this hit actor we cast to road actor. If it is road actor, create a branch. When this true, pass to road actor and add local input is hit road actor. Boolean. Set this to true. Set road network. Set this road actor. And then we call break this loop. And we return on complete. Go to event graph and go to target location event. Before we add path location to target, we need to call should use road actor. For this function, we collect this function first and rename this to create a road network path. get road network and call is valid. If the road network is valid, we call the function find path road network. And if it's not valid, we use the straight path. So the start location is vector location, and the target location is final target location. And go to event graph. In spawn new spline, when we add this spline point, this location, we need to break it. Make vector x to x, y to y, and to this position, add z. Get road network, all is valid. And select float. If it is valid, we want to move this position a little bit higher for the road thickness. So our road thickness is 5, so set it to 5. We can disable this debug. Let's play. Now you can see the vehicle can find the path in the road network to this location. Example, if this location is the target, the vehicle need to go here, then get to this location. We can close the project, save selected, go to algorithm bp library.cpp and .h. Under this add midpoint if far apart function, we add another function. Static void. We can copy this function because this function will have the same input. We name this to refine path with midpoint. Copy this to algorithm bp library.cpp. Under this, as here, and we don't need this static. If path points dot num less than 2, interpolated paths equal path points and return. Interpolated path equal path points. Full we edit midpoints. Do we edit midpoint equal false. Here a vector path dot add interpolated path 0 for incertitude I equal to 1, I less than interpolated path dot num plus I f vector previous point for path dot last f vector current point equal interpolated path and I. And we calculate the distance float f vector is from previous point to current point. If distance greater than max distance threshold, f vector midpoint equal to previous point plus current point multiply with 0.5 f temp at dot add midpoint b edit midpoint equal true. And temp dot add current point interpolate it path equal temp path while we edit midpoints. This midpoint is small letter. So this function, we add the midpoint to the spline until we have the distance that is less than max distance threshold. Go to road actor.h and this function we change to return t-array of f vector. This road actor array app vector. We copy this array app vector path and this path equal to pathfinding component get location from path nodes. Before this, we can call path. After this, we can call path insert start location to 0 and the target location we add target location to the array. We don't need to debug this, so let's delete this draw debug sphere. In this find path road network, we forget to return this path array. Save and run again. And this BP we call AI to event graph. In this create road network path. For find path road network, we can call refine path with midpoints. Make distance get grid gap to float multiply by 2 next to this make distance threshold. This array we select path to remove the sharp angle, so set to 5. Select vector is 0.5. Then set path to final target array. Now save. Let's play. Now we have this path that follow the road network to the target location. Next, we need to visualize this line. We create a new material M translucent. Then choose the color. Green is 0.8 and blue 0.35 and click OK. Click on this result node of the material and change this blend mode to translucent. Press 1 on the keyboard and left click on the mouse. And this is opacity set to 0.8. And we create convert to parameter color. Create material instance from this. Go to BP Spline road. Add variable mesh component and change this variable type to Spline mesh component. Primary path. Boolean. Section length. Float. And material instance. Variable type is material instance dynamic. Create a new custom event. Set visualize path. And input. This input name is primary path. And then set to this primary path. Get actor scale 3D. Split. X value we multiply with 100. And set to section length. Get spline. Get spline length. Divide by section length. Truncate. Then call for loop. We need to add the mesh on this spline. And this index we reroute. Add spline mesh component. Set mesh component. Get primary path. Select integer 1 and 2. And we call that translucent sort priority. We need to change the priority if two splines that have the same translucent, it will cause problem when it's overlap each other, the material of this translucent. Get mesh component or set material. And we set the material instance. Then we want to change the color of this material instance. Set vector parameter value and change the color. Change the color to blue. Next, we get material component. Set forward axis. In forward axis, x-axis. And the last node is set start and end. We get section length, multiply, and another one is section length multiply with this index. This one we add it with 1 before we multiply. Then get spline. This spline get location and distance along spline. This distance coordinate space is local. Write this vector make vector x to x, y to y, and z subtract get primary path, select float. If this true, we set it to -1. If it false, -2. We don't want two splines overlap each other. And connect to start position. Next, we can copy this. And we can delete this Z. And change to world coordinate space. Clamp vector size. Max is the section length. And connect to start tangent. This distance we use this section length multiply with index. And we can copy all of this. Use this distance. And we connect to add post and add tangent. This section length, we need to download the mesh for this line. I will put the link in the description so you can download this. drag it in here and don't need the material. Import all. When you open this, you can see approx size is 283 multiplied with 171. So the section length is 283. Choose this mesh in this add spline mesh component. Use this add mesh and change this mobility to movable. We need to create material in begin play. Let's create dynamic material instance. Translucent instant. Use this material instant. And then set to material instant variable. Go to BP vehicle AI. In this event, generate path spline. After we spawn new spline, we need to set visualize path. And primary path is false. Under this is go to target location. And after we spawn new spline, set visualize path. Primary path is true. So the primary path is green and the secondary path is blue. And this set spline point move data, get spline actor, like this. Get material instant. Or set with the parameter value. Color. And change this to blue. Dark blue. Compile this. Go to level blueprint. And we don't need to show the spline anymore because we have the visualize. We have a little bit of mistake here. This tangent, we need to get tangent, not location. Get tangent distance at distance along spline. Set this to world. The same with this. For loop, we connect this to last index, not the first index. And now we can see this spline. So we need to change this material and delete this material. And this is the main spline, is green. And the spline for avoid the obstacle or do the turn is blue. We can go to BP vehicle AI and final target arrival. Let's disconnect this. Draw debug sphere. Add the final target. Can delete this. Save all. Now we need to change this detect obstacle. We want to use this motion trajectory component to detect the obstacle. So edit this motion trajectory. Can close all of this. And we don't need this on force sphere because we won't use force sphere in this tutorial. And delete this force sphere. We can delete update force sphere function, debug force sphere and force sphere. And this force sphere array set make future position to 5 and make history position to 10. In this begin play, get owner has to BP we call AI. Then set we call owner. Promote this to variable. Name it to we call owner. And this update history position event we call predict future position when this array full. Create a branch if this true. Create a custom event. Name this trace obstacle. And after this loop complete, we call this event trace obstacle. Next, we add variable. This variable name is detect boolean. To this event trace obstacle, get vehicle owner False is valid. When this is true, text set to false. Get future positions. Call for each loop. Get future positions for each valid index. And get this index. Add it with 1 for the next index. Check if it's valid. And get a copy from this future position with this array index and this next array index. We add a branch. Then break this vector, make vector x and y, z, add with 80 to z. And we get unit direction, rotate from x vector, get vehicle owner, get actor rotation, get vehicle owner, get vehicle movement component. Get forward speed, and greater than 1. Then we select rotator. If it's true, we use this direction rotation, and if it's false, we use vehicle rotation. And then we get collision box. Check if it is valid. Get box extend. Call box trace by channel. And this is the start location, and this is the end location. This half side is box extend, and this is the orientation. We can draw debug this for one frame. Create a branch. If this detect is true, we continue the loop. If this detect is false, we set detect to true. Compile this to vehicle AI. In this initialize vehicle variable, we delete this bound force field, and we need to set this bug collision. And dynamic obstacle, we have this error because we don't have this event anymore. Let's delete this. Go to vehicle AI and viewport. We need to change this bug collision to the size of the vehicle. Let's set this bug extent to 300, 120, and 50. Next, go to event graph and this detect obstacle, get movement trajectory component, get detect, and connect to this branch. Delete this detect obstacle. Go to moment trajectory and this predict future positions. Prediction interval we change to 2. Let's move this obstacle in the middle of the road. And we save all. Let's play. You can see when this bug overlap with this obstacle, we generate the new avoiding obstacle spline. And it is working. We can disable the debug in this moment trajectory. Set this bug trace by channel to none. This is the end of our tutorial. In the next tutorial, we will optimize and adjust this spline to the right side of this road network and fix this location of the spline. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. Thank you very much for watching. See you in the next tutorial.